That was weird. Yeah, totally. Alright, that's better. Alright, how's it going? Good-ish.
I do feel like you're gonna this product or this get into a high security after class.
That's possible. We're already in a high security facility.
Jump into break cut glass using your print glass.
Yeah, and then jump out of a helicopter. Yeah, suitcase.
and that's when it fills with $1 billion.
Yes, exactly. All right, so first of all, I posted an announcement on Canvas. So tomorrow, I'm not going to lecture on new material. I will be here for both sections, but it's going to be kind of like an open lab. So if you want to come in and work on PA1 or anything else, and want to show me code, want to ask questions, want me to point you in directions with debugging or whatever, right? This will be a resource for you. So I'm not taking attendance tomorrow. If you have nothing that you feel would benefit you from doing a 50-minute open lab in 223, you can, do something else. But I recommend, if you're trying to figure something out, if you've been playing with Eclipse or IntelliJ and you're trying to get that to work, or obviously if you're working on PA1 and you're getting something weird or some problem, right? It's a really good chance to show me stuff, ask me questions, things like that. So some one-on-one time, but it'll be during the class. And we'll see how that goes. If nobody shows up and it's just a dead 15 minutes, then I won't do this again. But if it seems useful, I may make it a semi-regular thing as kind of a lab. And my understanding is at WSU, this part of some of the courses, you have a lab per week where you basically go in, you can work on stuff. And if you got your stuff done, you can leave. But if you want to ask questions, get help, show code, things like that, it's there. So we'll see how that goes. Does that make sense? So, and you can come to either section, both sections, it's up to you, or no sections. So no new material tomorrow. And then Friday, we will review PA1. I probably won't go through code on Friday in case anyone's turning it in 24 hours late. But we can talk about more questions. And then mainly Friday, we're going to go over PA2, which is going to be linked lists and strings and linked lists of linked lists and all sorts of good stuff. And I will try to post PA2 Thursday night, maybe earlier. So I was working with someone earlier and did the following. If you're trying to debug, say, your reduce function, right, for doing Euclids, but in general, if you want to do some kind of function, so let's say we're trying to write a function that multiplies an argument by 2. Okay, so we're writing this function twice. It takes x, it should return 2 times x. And I want to know if this works, so in my main code I'm just saying print line twice of I equals, and I'm just going to initialize I to 7. And we're just going to use this to test our function that we're developing, right? And when you try to compile it, you get this weird error about non-static methods. And I'm not ready to talk about what exactly this means yet. We have to get into static versus class things. And if you Google, you will find that if you put the keyword static in front of int twice, this will suddenly start working. And you've taken your first step down a very dark and dangerous and twisty path. And if you don't understand what that error message means or why you're putting the keyword static in here, you can find yourself just, it's like an addiction. You just start putting static in every time that you get this error, and more of your code has the static in it, and then all of a sudden one day you try to do something like make a fraction class, and you put static in and it doesn't work. And it says this can't be static. And so you start taking static out and your old errors come back, and now you've just got this quagmire, right? So I'm going to say stay away from the keyword static except for public static void main. Okay, until we actually go through and talk about this. So how do we do something like this to test this code? So the solution is put this in a separate class. So up here, I'm going to say I'm going to make a new class called test, and that's where I'm going to put my code for my twice function. And in my main method, I'm going to say, let's construct a new test object, and we'll call it t, and then I'm going to call t.twice. And this function is going to go inside my test class. Like that. So now we can test our function and we can develop it and debug it and so on and so forth. And so if you're working on your GCD function, for example, which doesn't necessarily have anything to do with fractions, right? GCD is something that takes two integers and returns an integer, and it uses Euclid's algorithm, right? You could develop that in here and put in your debugs and use print statements and so on and so forth. And you call it by just constructing a test object and then calling, t.gcd parentheses 5000 comma 28 or whatever. Does that make sense?
So I just should not use static at all. So if I've already done that, I should go back and...
If your code works, leave it as it is, okay, for now. I'm not going to take off points for it, right? But try to figure out how to make it work without using statics. In fact, that would be a good thing to talk about tomorrow during class if you want.
Okay.
But yeah, keep your code as it is. If it works, submit that, and so on and so forth. And then if you want to try to take it out, make a copy in a totally new directory and start monkeying with that, right? And in general, it's not unreasonable to have several copies of your code at one point on your system, and each copy ideally in a separate directory. Don't put in test code 1, test code 2, real code I'm going to turn in all in the same directory. It's just kind of asking for confusion. So get in the habit of, you're in a Unix environment, make separate directories, copy your code over. There's nothing wrong with having your fraction class in 6 different directories. That's perfectly fine. If you want to be fancy, make a link to it. have one copy of your fraction code in some, pristine area, and if you just want to use that somewhere else, make a link to it. And now if you edit it in any of your directories, it'll change all the copies of it because they're all the same copy. There's lots of stuff you can do, right? Think Unix environment, think 224, use it to your advantage. All right, any other questions? I was going to make you a checklist for 223's PA1. I didn't get around to it, but let's talk through a really brief checklist. So important things to make sure with your submission. So make sure your class is named fraction, uppercase F, no S on the end, okay? It's got to be exactly like this. Make sure you're only submitting fraction.java. And if you have some other class that you're using inside fraction.java, which I don't think anybody is, but if you are, you can also put that in there. Okay? Don't include a main method. Main.java, test.java, mytest.java, don't put those in your tar file. Okay, so it's probably just going to be fraction.java. Make sure you've got all the constructors, methods. Make sure your add submul div return fractions, not strings. Make sure toString returns a string, doesn't print anything. Reduce is totally up to you. You're not required to implement it. Make sure things are in lowest form. Make sure if the denominator is 0, you're handling that correctly. In particular, I don't have this in the test program, but if you take 0 over 1 and you divide by 1 over 0, that should end up being undefined. Right? Because 1 over 0 is undefined. Anything you do with an undefined should be undefined. If you don't check for this and you just use the regular algorithm that you use for dividing two fractions, this will incorrectly give you 0 over 1. And you'll have an undefined number and you do something to it and you end up with just plain old 0. That's wrong. Okay, so make sure that in all of these methods you make sure that the numbers are not undefined. If the number's undefined, just return 1 over 0. All right, header block in the beginning of your class with your name, date, class, assignment number, synopsis of what the class does in your own words, and then comments on your methods, comments on lines of code, sections of code, right? If you've got 6 lines of code here that's doing Euclid's algorithm, there better be a comment somewhere saying, find the greatest common denominator using Euclid's algorithm. Right, that would be a minimum that you'd expect for that chunk of code. So a couple of test programs on the server, you can use those to make sure that it passes those tests. Don't use a package statement. Make sure you create the tar file from the directory in which the Java file is found. So it's just tar cvf pa1.tar and then fraction.java probably. Okay, so that when you untar, it drops those files into the current directory. And then upload the tar file to Canvas. And I recommend, since it's 5 points for this correct submission, I recommend after you upload to Canvas, do the reverse process. Okay, so go to Canvas, download your submission, which will dump it on your laptop, and then copy that over to the Linux server in a new directory. Go in that new directory, untar javac or Java file, and then copy over your test program, compile that, execute it, make sure it still works. That takes care of, I forgot to put the correct thing in the jar file, in the tar file, or I have a corrupt tar file, or you know, I uploaded the wrong file, all these other things. Okay, so go through the process that I'll be going through. That's just a good acid test. All right, we ready to talk lists? All right, so we know what linked lists are, right? Our favorite picture. So there's a linked list with 3 nodes, assuming that the first one's not a Sentinel. So linked list, we have blocks which are nodes. They contain some sort of data, and they contain a pointer to the next node in the list. And starting with the first one, we can follow this chain of pointers and eventually hit the end of the list. And now we've got everything that's in the linked list. So let's look at implementing this in Java. And in Java, we're going to create a class called list, or linked list, or whatever we want. And when we want to create an empty list, we could say something like, let's say my class is called myList. So myList list equals new myList. And that's going to create an empty list. And then I can do things like list.add, list.delete, list.search, and so on. So let's do a linked list of integers, because that's what we always do apparently. So first thing we're going to need is a linked list node. So I'm going to make a class called node. And so what are the pieces of a linked list node? Okay, there's a next field. What kind of thing should next be? It should be a node. And then piece of data, which we're just going to do integers. And that's kind of it. Now, just because I'm kind of OCD, I'm going to put data before next. Doesn't make any difference, but I don't want you to think that there's some reason why every time we did this in 222, it was data and then next, and now it's like switched around. Could be either way. Okay, well, let's just leave that for now. And let's start the list class. And let's not do a Sentinel node. Sentinels work in C really well, partially because C is a little quirky about passing around objects and stuff. When we have an object, once we say something like myList list equals new myList, list is not null. List is an object. It's a list object. And if we want the pointer to the first node to be null, that's perfectly fine. that doesn't stop list from existing. List is not null. The thing inside that refers to the first node is null. That's okay. So sentinels aren't going to be as necessary convenience-wise in an object-oriented setup. So we're not going to have a sentinel node. So the main thing that we need is a way to get to this first node. So I'm going to make a node called first node. And it's going to be null if the list is empty. And let's make a constructor. So I'm going to make this private because I don't want anybody messing around with my first node. So we'll make a constructor, and I forgot this is my list. And the only thing the constructor is going to do is set the first node equal to null, which means when we construct a list, we actually have an empty list. All right, let's make an add routine. And since I don't want to write PA2 for you, we're just going to add to the beginning of a list. Okay, you may want to do something fancier in PA2 like insert so that your list is in order, for example. But let's just add something to the beginning of the list. So if first node is referring to the first node of the list, say this is what our list looks like, and let's say we want to add the number 20. So we want to have a 20 sitting here in the beginning of the list now, and the 20 is going to point to the 2, and then to the 5, and then to the 10. So this is add in the beginning of the list. So what kinds of things do we have to do to the list? This is first node. So this is what we have before we do the add. So what should it look like after we do the add? What changes in this picture? Yeah, so first node points to a 20, and that points to a 2, that points to a 5, that points to a 10, and that's null. So this is before, this is after. Well, how do we make that happen? So if we break this down into steps that we believe are small enough that we could write these in lines of Java code, what are the steps in going from here to here?
Create the node for the 20.
Okay, make a new node. Make a new node that looks like that. What comes next?
Make 20 point to 2.
Okay. And then?
First node needs to point to 20.
And then I think we're good to go, because 2 is going to be pointing to 5, which points to 10. The rest of this is all fine. Okay, so how do we make a new node? We're going to use the constructor in the node class. How do we make the new node point to the 2? Yeah, we just set the next field. What do we set the next field equal to? Set it equal to first node. And to make the first node point to 20, we just set first node equal to whatever our new node is. Well, we can code that exactly like we just said it. So let's do this. So create a new node containing num. So this is node, new node equals new node, num. And we'll have to write a constructor that does this in our node class. But we'll go back and add that shortly. All right, have this new node point to first node. And then have first node point to this new first node. And that's all we got to do to add.
Should we also set that value too? Or whatever.
So I'm assuming that our constructor will take an integer. But we got to still write that, yes. Right, or use the default constructor and then set new node.data equal to num.
Don't we also need an existential flag to see if the new node or first node even exists?
Yes, so if we start off and first node is equal to null, and we set, well actually, I think this will work actually. Yeah, because we're adding it at the beginning. If we added it after and we wanted to start searching through, before we do that search, we need to see if first node is null. All right, that's the difference. So for this, if first node's null, we'll create a new node. Its next will become null, which is correct, and then first node will point to the new node. So let's make our constructor in our node class. So let's say public node integer value. And I'm just going to be nice and I'm going to set next equal to null. Just in case the user is assuming that. Alright, so now we can construct our node. So this should be a good add method. So how should we tell if we've succeeded in adding nodes to the beginning of the list or not? How do we want to look at our list?
Two-string.
Let's use a toString. So we're going to build up a return value string again. We'll initialize return value to be just a string that has nothing, so this is a string. Alright, so how do we go through our list? We start with first node. We print out its data value, or in this case we concatenate it to our string, and then we move to what that points to. We add that value, we move to what that points to, we add that value, and we stop this when the thing that we're pointing to is null. And if our list is null to begin with, first node will be null. So let's check this condition at the top of our loop. So we'll write this and then we'll think about whether it works. So node temp equals first node. And I'm going to lose my network connection. I don't know why I went ahead and did this on the server. Excuse me a second while I type in really quickly. Alright, so there's a constructor. First node is a node. There's our add method. And so let's do our two-string methods. So node temp equals first node. This is the node we're about to append to return value. And if temp is null, then we're done. So we're going to say, well, temp is not equal to null. So return value equals return value plus temp.data, and we'll just add a space on the end. And when we're done, we'll just return value. So that's like what we did with our stack when we were dumping it as a string. So there's our whole MyList class. Basically, we can construct, we can add, and we can convert to a string. How are we doing over here? We're still dead. Alright, so let's make our node class. Alright, do we have anything else in our node class other than comments? So data next, we can construct with a number, and it sets the data equal to the number. Alright, should we try this? So my list equals new my list. That should be an empty linked list. And let's print out the initial list, which should just be a single space. It should be empty, actually, an empty string. And then let's add some stuff to the beginning of the list. So we'll add 4 things in there. And then let's print out what the list looks like after we added 4 things. And it should be minus 101 in the beginning, 13, 37, 23. Got a plus sign. So, same thing as in C. When you get a bunch of error messages, go after your first error message. I think this last one is legitimate, but it could all be coming from the fact that there's an error at line 5, which is my missing plus sign. So always look at your first message, fix that, and then recompile. I don't know if we did this in 224, but since it's telling me line 5 of main.java, you can say vi plus 5 main.java, and it starts you off at line 5. That's not big for 5, but if it's line 235, that's an easy way to get there. So I'm going to put my plus sign in there, and I'm also going to have that problem down here, so I'll fix that. And then let's recompile. So I forgot to put a type of return on add. So let's go to line 10 of mylist.java. And add does not return anything. So I'll just return void. So compile everything. Java main. Initial list is empty. Wow, that's slow, man. Am I crashing my machine? Oh, yeah. I'm not crashing it, but I've got an infinite loop. And none of you caught it. So in the toString method, right? Yeah, I'm not changing temp. So move down the list, go on to the next node, right? And so I was building a really, really long string there. All right, so easy fix. Compile that. Run your program. Looks like list traversal works. There's a linked list. Right? And this is how lists should be interacted with, right? Construct a list, and then you can say list.add, list.delete, list.search, and so on and so forth. Now, if I do something like this in my main program, list.firstNode equals null, right, I found a sneaky way to truncate my list. And that may or may not be a bad thing, because it may be that in my delete function, I decrement a counter, and in my add function I increment a counter, and I have a length function that tells me how many things are in my list. And instead of counting the nodes in my list, which could take a long time for a big list, I keep track of how many times I've added and how many times I've deleted. And when you ask for the length of a list, I just say, here's the counter's value. And if you come in from outside and you zero out your list by setting first node to null, my counter is not working right. If you ask for the length of this list, my code would tell you the list has 4 things in it because you added 4 things and you deleted 0 things. So you messed up my code by changing first node. So this is one of the reasons that we would do something like this. Make that private. And now when you try to mess up, it's going to say, hey, you can't touch first node.
With that last part, can you get, so earlier you mentioned that it takes care of all of its own memory internally.
Mm-hmm.
If you were to do that, would it automatically free those 2?
Those will get freed eventually,
Okay.
yeah.
Okay, so it's just not immediate then?
It's periodic. So there's a garbage collector, and it wakes up once in a while, and I don't really know how the garbage collector works. The last time I really looked at garbage collection was back in Lisp, which was in the 80s. But in Lisp, it would wake up periodically and go through and look for things that didn't have references to them. And it's probably fancier than that in the JVM. But it's not instantaneous, because I know when you go into JDB, you can use the GC command to say, go ahead and garbage collect. And sort of force it to do it right then. All right, so we can make the first node private, and that's the only field inside the my list. We could make these private as well inside our node class. But if we do that, we break my list, because my list is accessing those fields in the node. So you've got a few possibilities. We could make some accessors and mutators so that we can access these things through methods. We could make these things what are called protected instead of private. Protected is kind of in between private and public. And it means that other things in what's called the package, we have to talk about packages still, but other things that are a part of the same system basically have access to this, but the general user doesn't. And I think package protected is the default if we don't specify. But in reality, there's nothing wrong with exposing these fields of the node, because the only node that mylist refers to is first node. And since we can't get to first node, we can't get to first node.next or first node.data, and we can't get to what first node next points to because we can't get to first node next. So our data is already secure because this first node of the list is protected, right? It's private. So you don't have to go crazy with making things private. But in general, you want to have as little visibility as necessary. You don't want to hide things that the user wants to get to. For example, if I made my add method private, whoever's creating a list couldn't add things to it. It would say you can't access the add method. But if I had some internal add method that did something else and I didn't want the user to call it, I could make that private. Or if I had other things like a count of how many nodes there were in the list. Right, I would certainly make that private and then expose it through something like a length method. All right, so people comfortable with this? So suppose I wanted to make a linked list of strings instead of integers. What all would I have to change in this mylist class? Want a linked list of strings.
Change your variable type, right? For the first thing in your class, you want to change your variable type from storing integers to strings.
So variable type of what?
Yeah.
Okay, so we'll come to node next, but inside my list, what do we have to change?
The add,
The add, what about it?
it's adding a number.
Yeah, so just the argument type. Anything else? How confident are we that that's it?
Well, the string, you're fine.
Yeah. That's all we got to change in here. One thing. Change that one int to the word string. Now in our node, the node actually defines what the node is, and here it's got to hold a string instead of an int. Well, we got to change two things in here. Right? We've got to change this, and we've got to change the argument here. And that's it. All right, so let's add some strings. So we definitely have to change how we call the add method because we want to pass it strings. Hey, guess what? All the code still works. We didn't really change any functional code. We changed a few declarations from int to string. And if we wanted a linked list of doubles, we would change string to the word double. Or booleans. If we wanted a linked list of linked lists, we could change string to my list. And we could now make a linked list of linked lists. If we wanted stacks, we could change it to stack or rectangle or anything else. Right? This is part of what objects buy for us. The code is fairly agnostic to what it is that we're manipulating. We can write the algorithm without getting bogged down about the fact this is a string, so it's got to be a pointer to a car. This is an int, so it's an int. This is an array, so it's got to have brackets, right? Objects are objects. And this happens so much that there's a concept in most modern languages, including Java, called generics. And we can actually write this class, and instead of saying int or string or rect, we can put in a placeholder and say, when you construct a list, tell me what kinds of things you're going to put in there. And we'd say my list, angle bracket, string. And then that placeholder would get replaced with the word string, and it would do what we just did with the editor. And now we have a linked list of strings. So we'll talk about generics in a few weeks too. All right, if you did not sign in, I'll leave this up here. Come on up and put your signature on there. I will see you tomorrow. We'll be doing Open Lab again, so bring in